Yes, a sub-panel can be fed from the unused main lugs on a 100 amp 120/240 volts panel. Since the main breaker is 100 amps, the 10-foot tap rule is applicable. The 10-foot tap rule allows for an extension of the feeder conductors for a sub-panel up to 10 feet from the overcurrent protective device, which in this case is a 100 amp breaker, without needing a separate disconnect switch. The maximum sub-panel size is determined by the conductor ampacity used for the feeder to the sub-panel. Using the 10-foot tap rule, conductors rated up to 100 amps can be used. Consequently, a sub-panel of up to 100 amps can be fed. When installing the sub-panel, firstly, install a ground bar in the sub-panel. Secondly, connect the ground wire from the main panel to the ground bar. Thirdly, connect the neutral wire from the main panel to the neutral bar in the sub-panel. Fourthly, connect the hot wires from the main panel to the appropriate circuit breakers in the sub-panel. Fifthly, label all breakers clearly. Sixthly, install a sub-panel cover. It is crucial to ensure the total load on both the main panel and the sub-panel does not exceed the main breaker's rating of 100 amps. If you are not comfortable performing electrical work, consulting with a qualified electrician is advised. Understanding the 10-foot tap rule is essential. This rule, as defined in the National Electrical Code or NEC, specifically in section 240.21, B1, offers flexibility in certain scenarios. It allows you to tap a set of conductors from a larger feeder without requiring an overcurrent protection device at the tap point, provided specific conditions are met. Firstly, the tap conductor's ampacity must not be less than the calculated load they will serve. Secondly, the tap conductor's ampacity must not be less than 1/10 of the rating of the overcurrent device protecting the feeder from which they are tapped. Thirdly, the tap conductors must not extend beyond 10 feet in length. Fourthly, the tap conductors must be enclosed in a raceway or be installed in a manner providing equivalent protection from physical damage. Fifthly, the tap conductors must terminate in a single circuit breaker or a single set of fuses that will limit the load to the ampacity of the tap conductors. Applying this to the situation, firstly, the 10-foot length limitation is critical. The conductors feeding the sub-panel from the main panel's lugs cannot be longer than 10 feet. Secondly, calculate the load. Determine the total amperage the sub-panel is expected to carry based on the circuits and devices that will be connected to it. The conductors feeding the sub-panel must have an ampacity equal to or greater than this calculated load. Thirdly, conductor size. The conductors must have an ampacity that is at least 1/10 of the 100 amp breaker protecting the main panel. In this case, that would be 10 amps. However, always use conductors with an ampacity rating that matches the intended load of the sub-panel, and consider using conductors with an ampacity up to the 100 amp capacity of the main breaker to allow for future expansion. Fourthly, overcurrent protection. The sub-panel must have its own set of overcurrent protection devices, such as circuit breakers, to protect the individual circuits within the sub-panel. The size of the main breaker in the sub-panel should not exceed the ampacity of the conductors feeding it from the main panel. Fifthly, grounding and bonding. Proper grounding and bonding are crucial for safety. The sub-panel must have a grounding electrode conductor connected to an appropriate grounding electrode, such as the ground rod or the metal water pipe system. The neutral conductor must be isolated from the sub-panel enclosure and connected to a neutral bus bar that is also isolated from the enclosure. The equipment grounding conductors must be connected to a separate grounding bus bar that is bonded to the sub-panel enclosure. Sixthly, conductor type. Use conductors that are rated for the application and environment in which they will be installed. THHN or THWN conductors are commonly used for this type of installation. Seventhly, connections. Ensure all connections are made properly and are tightened to the manufacturer's specifications. Use a torque wrench to ensure the correct torque is applied to the terminals. Eighthly, labeling. Clearly label all breakers and circuits in both the main panel and the sub-panel. This will help with future troubleshooting and maintenance. Ninthly, inspection. Once the installation is complete, have it inspected by a qualified electrical inspector to ensure it meets all applicable codes and regulations. Tenthly, safety. Always work safely when performing electrical work. Turn off the power to the circuit before working on it, and use appropriate personal protective equipment such as insulated gloves and safety glasses. Regarding the maximum size of the sub-panel, it is important to clarify that while you can use conductors rated up to 100 amps with the 10-foot tap rule, this does not necessarily mean you should install a 100 amp main breaker in the sub-panel. The appropriate size of the main breaker in the sub-panel depends on the calculated load and the ampacity of the conductors feeding the sub-panel. If the calculated load is less than 100 amps, you should use a smaller main breaker in the sub-panel to protect the conductors and equipment from overcurrent. Additionally, be mindful of the total load in the main panel. The combined load of the main panel and the sub-panel must not exceed the rating of the main breaker in the main panel, which is 100 amps in this case. Performing a load calculation is essential to ensure that the main panel can handle the additional load of the sub-panel. Several factors must be considered when calculating the load. Firstly, general lighting. Estimate the total wattage of all lighting fixtures that will be connected to the sub-panel. For general purpose lighting, you can typically use a value of 3 volt amps per square foot for residential occupancies. Secondly, receptacle outlets. For general purpose receptacle outlets, use a value of 180 volt amps per outlet. For specific appliances, such as refrigerators, washing machines, and dryers, use the actual nameplate rating of the appliance. Thirdly, fixed appliances. For fixed appliances, such as water heaters, dishwashers, and HVAC equipment, use the actual nameplate rating of the appliance. Fourthly, motors. For motors, use the value specified in NEC Table 430.248 for single-phase motors and NEC Table 430.250 for three-phase motors. Fifthly, demand factors. In some cases, you may be able to apply demand factors to reduce the calculated load. Demand factors are based on the assumption that not all loads will be operating at the same time. Refer to NEC Article 220 for information on demand factors. To calculate the total load, firstly, list all of the loads that will be connected to the sub-panel. Secondly, determine the volt amps for each load. Thirdly, apply any applicable demand factors. Fourthly, add up all of the loads to get the total calculated load. The total calculated load must not exceed the ampacity of the conductors feeding the sub-panel or the rating of the main breaker in the sub-panel. Regarding sub-panel installation, always energize the circuit before working on any electrical equipment. Turn off the main breaker in the main panel that is feeding the sub-panel. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment such as insulated gloves and safety glasses. Use insulated tools. Follow the manufacturer's instructions for installing the sub-panel and all of its components. Install the sub-panel in a location that is dry and accessible. Ensure that there is adequate space around the sub-panel for working and maintenance. Mount the sub-panel securely to a wall or other suitable surface. Connect the conductors to the sub-panel according to the wiring diagram. Use the correct size and type of conductors for the application. Tighten all connections to the manufacturer's specifications. Ground the sub-panel properly. Connect the grounding electrode conductor to the grounding bus bar in a sub-panel. Bond the sub-panel enclosure to the grounding system. Isolate the neutral conductor from the sub-panel enclosure. Connect the neutral conductor to the neutral bus bar in the sub-panel. Label all breakers and circuits clearly. Use a circuit directory to identify the circuits that are served by each breaker. Install a sub-panel cover to protect the components from damage and to prevent accidental contact with live parts. Inspect the installation carefully to ensure that everything is installed correctly and safely. Check all connections to make sure they are tight. Verify that the grounding and bonding are properly installed. Once the installation is complete, have it inspected by a qualified electrical inspector to ensure that it meets all applicable codes and regulations. Remember, safety is paramount. Electrical work can be dangerous. If you are not comfortable performing electrical work, consult with a qualified electrician.